Hello, my name is Samuel Kundi, and in this video, I'll be discussing my Lab 1. In this lab, I had to observe the motion of a ball that was moving at the same speed without changing directions. These observations will be pulled from data obtained from the program tracker. I'll then compare these observations to a computational model base these observations off of Newton's second law, which is F net or net force equals mass times acceleration. So from my experiment, what I did was I used a rubber ball and moved it across my bedroom floor. I then uploaded the video through Tracker and was able to collect its motion through a selected time frame. And as you can see from this video, I was able to make note of its the center of the ball as it moved across the floor in this selected time frame. And I was able to make note of its motion, as you can see from the graph of this position versus time graph. And as you can see from this diagonal line is a constant velocity, so it doesn't change directions, and also a chart to make note of each of its position change at each time change. And from there, I was able to gain its initial position, which is 0.001472 meters, its initial velocity, negative 0.49 meters per second, which I got from dividing the difference between the second and first positions by the difference between the second and first times. And all this was pulled from the graph in Tracker. And so I then uploaded these values through starter code that I uploaded through glowscript.org. And I was able to add its initial position, as you can see from line 34, line 35, its initial velocity. And I was able to change balls less than the final time, the zero vector, and I was able to add F net over ball of the mass of the ball for basically to update to include Newton's second law, which was very vital to showcase constant velocity. And so when you run the program, you're able to get a chart, a position versus time graph that shows basically the constant velocity of this ball through this certain time frame. And so I uploaded the graphs, or I guess the data from each graph to showcase the comparison between the two. And as you can see from this model position versus experiment position graph, you're able to notice, I guess, the difference and similarities between the two data tables. So from the experiment position, which is the blue line, it's a little, you can notice that it's a little bit hovering over the model position line, which is in red. And one reason why I noticed that is because how maybe this could deal with some of the changes in the ball when I rolled it across the floor, how it may have swayed in its motion as I moved it across, and maybe the surface of the floor could have played a role into the way the ball moved. And that could have made a slight alter in predictions between how it was in my experiment between the model that was showcasing GlowScript. But it's similar in the sense that both are downward sloping, and it constitutes with when F net is zero. When F net is zero, that means it's not changing direction because that means acceleration is zero. So when acceleration is zero, that means F net is zero. So that just showcases constant velocity. You can see from this downward sloping line. So that's a very key similarity in my experiment and model lines. And so finally, a few questions. What if I altered the axes from my experiment? Well, that would mean that by rotating it to the y-axis instead of keeping it at the x-axis, basically gravity would have to be taken into account, and that would prove to be very I guess, very complicated when dealing with an F net of 0 and dealing with this, I talk of Newton's second law. And basically, in regards to pushes and pulls, we can't really notice or can't really make note of pushes and pulls because Newton's second law only constitutes with net force of 0, and with net force 0, we can't really make any notes of any pushes or pulls.